Hi everyone. Sorry I can't be there with you in person, but I thought I would make a video for you during my absence. Something came up and yeah, I can explain myself once I see you. But for the moment, please bear with this video. Don't give the substitute a hard time. Please do not abuse the washroom system. Please listen to them and, explain if there are any questions that they might have, and also to follow instructions. If they feel that you are not focused, then they might say something. Well, let's get focused. Again, don't give them a hard time. You know my expectations as well. Please give them the respect and the effort that you normally would show me if I was in the classroom. So, lucky for us, our lesson today is something you've already seen before, but judging from our prerequisite mock quiz, as well as some other things that I've seen, I think it might be best to have a full lesson on the different rules for exponents. That is today, multiplying powers, what happens when you multiply, dividing powers, what happens when you divide, and power of a power, what happens when you have an exponent on top of an exponent. We're going through these examples. There are some homework questions that you can do. And of course, answer key is provided. If the examples that I go through are a little bit fast for you, then by all means, this video is going to be uploaded on our classroom so you can watch them there. Any questions you have, you can always reach out to me by email or wait until I come back and we'll deal with it. Sounds good? Here we go. Please feel comfortable, and as a substitute as well, please oblige students if they ask that the video be slightly paused for a couple of seconds, no more than 5-10 seconds, because they can, if they're having trouble copying, then they can always check the video once again on their own time, right? But I don't think it's going to be too difficult. Here we go. Powers. As you know, since we talked about it, powers are an abbreviation of multiplications multiple times. Get it? And so all we have to do is identify what the actual base is, what number is constantly being multiplied, and by how much. And that's simply it. But because this is what the system is, there are some interesting things that we can do to help, make our lives a little bit easier. And that's where these multiplying power laws, exponent laws come from. So let's start with the basics. Convert each power to expanded form. So recognizing that 2 to the power of 4 means a base of 2 is multiplied with itself 4 times is all you need to know. Okay. Next, -5 is the entire base, and 3 is the exponent, which means the entire negative and the 5 is being multiplied again and again and again, 3 times. C, however, this is what some people still made a mistake on during the quiz. You have to assume that by BEDMAS, the exponent comes before a multiplication or a subtraction or whatever that might be. Okay, so the answer to this is -3 multiplied by itself 4 times. Now, this might seem a little bit confusing, but maybe this can help you understand better. This is essentially the same as a -1 being multiplied to a 3 to the power of 4. And if you're multiplying by a 1, a value of 1, does that actually change the entire value? Not really. So mathematicians typically don't write a 1. They just say, oh, it's a negative. It's a -1. It's there. I don't want to write it though. So there it is. Okay, remember mathematicians, lazy. There it is. Yeah. I think that's the best way to look at it. I know it might seem like it's hocus pocus, but it's not. There are explanations to it. So maybe some other examples might raise better questions, and you can see it in different circumstances, which makes your life easier. Second example, convert the following expressions from expanded form to exponential, and then solve. So 4 is to the power of 5 because I see 4 be multiplied 5 different times. And if I were to do that, I could do that in the calculator, right? That's what 4 times 4 is 16, times 4 is 64, times 4 is 256, times 4 is 1028. 10, 20. So wait, that's a 4, 2. Oh, I fail you. I think it's a 2, 2, 4. Am I wrong? You know what? It's really late. Let me just bust out the calculator for a second. 2 to the power of 5. Oh, so it is 1024. Why am I thinking differently? 240. Oh, that's why. Yeah, 1024. I should have known better. This is a number that's very common in computers and stuff too. Anyways, next, when you take a look at this expression, you see that -2 is being repeated again and again. So again, ask yourself, what is the base? That's a -2. There it is. And f, it's essentially the same thing as up here. You see that what's repeating is the 3. The 3 is being repeated again and again. This, however, you can again interpret that as a -1 multiplied by the 3. So this, this is that, which is multiplied by 3, 3, and 3. And if you say -1 times 3 is -3, then well, we can do this first as 3 to the power of 4 and then multiply by a -1. Because when you multiply, order won't matter, right? 1 times 2, 2 times 1, same answer. I hope you get it. Okay, so that was review. I'm going to assume that it doesn't take you too long to do this, but again, you could always pause. Now might be a good time to have students catch up. If you are not pausing, I'm going to move on, or assuming that you did pause, I am going to move on. Knowing that that is what exponents mean, that is simply an expression, it's an abbreviation for multiplication. What happens when you multiply powers of the same base? Well, if I expanded this, so remember, this is 2, which is also the same equivalent of 2 to the power of 1, and that is 2 to the power of 4. If I were to expand this, that's 2 to the power of 1 is just 2, and I'll color code it with red. Okay, and 2 to the power of 4 is, 2 to the power of 4 is 2, 2, 2, 2. And that I will color code as blue. Right? And that's what expanded form is. But from there, if I were to simplify this into an exponent, what do you notice about these 2's? Well, not only are they all the same, but they're multiplying. So if I have a base of 2 multiplied this many times, the exponent should be a 5. Huh. Coincidence? Not really. When you are multiplying powers with the same base, what you can do as a shortcut is simply add the exponents. That's it. Every single time. Another example. Let's pretend I have 10 to the power of 99 multiplied by 10 to the power of 101. I'm not going to multiply all of that. I'm not going to write 10 times 10 times 10 times 10 times 10. I'm not going to write that 99 times and then do that again 101 times. Instead, because I know my exponent laws, I know that this is going to equal 10 to the power of 99 plus 101. This is going to be 10 to the power of 200. It's as simple as that. Remember, the condition is you have to have the same base and it's multiplying. So take a look. -5 and -5, same base. And the 2 powers are multiplying. Therefore, I can take this base as is and simply add the exponents. The final answer is -5 to the power of 3. Don't believe me? That's okay. What if I actually expanded it the way the question asked me to? -5 to the power of 2 is -5 times -5 times -5 to the power of 1. And guess what? How many times do you see the -5? It's 3. It's the same as 2 plus 1. And here comes the tricky one. Remember, I am going to rewrite this as a negative 3 to the power of 4 times 3 to the power of 1. Don't be tripped up. You can still use exponent laws. The final answer is going once, going twice, 3 to the power of 4 plus 1, it's negative 3 to the power of 5. Don't believe me? Well, that's a negative, and 3 to the power of 4 is 3, 3, 3, 3, multiplied by one more 3. There it is, 3 to the power of 5. The rule: when multiplying powers with the same base, add exponents. Now, before I move on to the dividing portion, I think you can guess it. If multiplying powers made you add the exponents, what do you think division is going to force you to do with the exponents? Going once, going twice, it's going to get you to subtract, which means sometimes you might end up with negative exponents. But if you want to subtract, you need to be good. You need to be okay with subtracting integers, which takes us all the way back to our prerequisite skills in the beginning of the semester. If you are still having some trouble with your integers and your number lines, you got to refresh that. Okay. I'm going to ask the substitute to pause this video if students are still copying. Otherwise, let's move on to dividing powers. Here we go. As I said before, if you are dividing exponents, because division could be a little complicated, I'm going to show you in multiple ways you can write division and still come up with the answer of 2 to the power of 4 minus the 2, which is 4 to the power 2 to the power of 2. Now, how did I get that? 2 to the power of 4 is 2 times 2 times 2 times 2. All of this is going to be divided by 2 times 2, right? Because all of this is divided by all of this. So where does that bring us? Well, remember, 2 and 2, it's sort of like saying 2 times 2 times 2 times 2 divided by a 2, and then divided by another 2 because it's underneath the bracket. So a multiplication of 2 and a division of 2 will essentially multiply and divide. It's going to reduce into a 1. Same with these two. Another way you could look at it is pretend you're multiplying fractions. Do you remember what happens? What if I multiply it by 2 over 2 times 2 over 2 times 2 over 1 times 2 over 1? Multiply across, I have 2 times 2 times 2 times 2 in the numerator, 2 times 2 times 1 times 1 in the denominator, which is essentially the same thing as what we have on the left side. So long story short, after all of that gregarious explanation, all you have to remember is if you are dividing, essentially 2 is being divided by itself. So anything divided by itself is a 1. And 2 divided by 2 and 2 divided by 2, we're basically reducing fractions. All that's left is 2 to the power of 2, because anything multiplied by 1 doesn't change anything. So instead of doing all of this, knowing that this is what's happening, we can take a shortcut and simply look at the exponents and subtract. Some of you might actually be copying this, so let me just write this out. 2, 2, 2, 2 over 2, 2. So we've got division 1, division 1, division 1, division to 1. 2 times 2, which is 2 to the power of 2. Okay. So again, I'm not going to write all of this. Being a mathematician, I'm a little bit lazy. So I notice that the bases are the same, which means all I have to do is take the exponents and subtract. And so the final answer is -5 to the power of 3. Okay. Last one, Same with this. Ooh, please be careful. This is negative 3 to the power of 5 divided by 3 to the power of 1. That negative, I know it's going to throw a lot of people off, but you have to get into the habit of thinking if it's not in brackets, that exponent does not apply to the negative. It only applies to the 3. A positive 3 is the base, which means I can use exponent laws. This is negative 3 to the power of 5 minus 1, which gives you negative 3 to the power of 4. So once again, same as before, if you have the same base and the question is asking you to divide, you just have to subtract the exponents. Okay. Remember, the video is all there for you. I'm going to ask the substitute to pause if need be. Otherwise, I'm moving on to power of a power, which is our last example of the day. Going once, going twice. Last examples. I think maybe I'll do every other question here. If you are stuck with some of these questions, that you can always check the answer key that I provide online. All of the other questions underneath are going to be practice questions for you to do in class, and then homework questions for you to try at home. Now, some of you might be rolling your eyes saying this is way too much for one day. It could be, but know that there are people in your grade who are able to finish this within your 20 to 40 minutes. And so if it's a struggle for you, that's fine, right? Maybe do A and C, maybe do A and C, maybe do A and C, maybe do A, C, and E, and be like, whew, that was 40 minutes. Others who are rolling their eyes because it's just annoying, do as much as you can for the 20 to 40 minutes, okay? If you're rolling your eyes because you can do it, but it's annoying, just still do it, still do it. Think about it as delayed gratification. But for those of you who are rolling your eyes and are not going to do it, don't build that habit. Okay, here we go. Our final rule of the day is a power of a power. And what that rule is if you see an exponent on top of an exponent like this, what's going to happen is not adding, you are going to multiply. So the answer to this is 2 to the power of 6, right? For this one, yeah, we'll get to that after. Okay, all right, so maybe we should be doing all of these independently. The explanation is this. 2 to the power of 3 is to the power of 2. So being a power of 2, that means 2 to the power of 3 is multiplying it by itself, with itself, twice. And what do we learn about multiplication of powers of the same base? Well, that would be 3 adding with itself, which is 2 to the power of 6. So you can add the 3 to by itself, or using a short form, you can simply do 3 times 2. They're going to give you the same thing. All right, let's try a harder question. Ooh, inside the bracket, there is an a to the power of 1 with b to the power of 2. I know that the 3 is going to multiply with everything inside the bracket, which means 3 multiplies with 1, and the 3 multiplies with the 2, giving you a to the power of 3 and b to the power of 6. But why? Once again, here's the proof. If I were to expand it out, this would be ab squared times ab squared times ab squared. Which if I, again, write it out, that's a times a times a. Okay, I jumped the gun. A times b squared times a times b squared times a times b squared. How many times am I multiplying a? 3 times, so it's 3 cubed. How many times am I multiplying b squared? 3 times, so it's b squared times b squared times b squared. And you know from exponent laws, that you are going to add the exponents because the base is the same. This is going to be b to the power of 6, which is agreeable with what I did in my previous shortcut. So the take home for that example is if you have multiple numbers inside inside the bracket as the base, that exponent will apply to every single exponent there. That is a to the power of 1 and b to the power of 2. This also applies to numbers as well. Let's try O. Some people might need a pause right there, but we'll keep going. I'll leave it to the discretion of the substitute. -3 to the power of 2. There's a couple of ways you can do this, but for now, I think the best way is, as the question suggests, open it up. -3 to the power of 2 is -3 times -3, which is a positive 9. Another way you could think about it in your head, if it works for you, is knowing that it's an even number. You know that the final number is going to be a plus. Next, knowing that it is 3, okay, this -3 to the power of 2. Knowing that the exponent is an even number, you know that's going to be a plus. Also, knowing that 3 has that invisible exponent of 1, when you apply the power of a power law, you know that it's going to be 3 to the power of 2, which is going to be 9. There's a variety of ways you could go about this, whatever works for you, whatever makes you feel comfortable. I think this is a fairly decent shortcut way to apply power of power law, but you may not think so. Let's see it in action in P. Okay, let's try this. You can multiply this out, or you can think about this as a -2 to the power of 1, a to the power of 3 squared. Ready? I see a negative. That's an even exponent. So my final answer will be a positive. This is 2 to the power of 2, because it's 1 times 2. This will be a to the power of 6, because it's 3 times 6. So my final answer is 4a to the power of 6. We'll try another one. This is 3 to the power of 1, a to the power of 1, b to the power of 2, and all to the power of 2. Once again, that exponent applies to everything inside the bracket. So this 1 times 2, this is 3 to the power of 2. 1 times 2, it's a to the power of 2. 2 times 2, this is b to the power of 4. So simplified, 9a squared b4. Not 6, by the way. 3 squared is 3 times 3. It's a 9. Lastly, see if you can work through this one. We have x to the power of 1, and that is multiplied to x to the power of 4 to the power of 3. Okay, let's do it. X to the power of 1 is going to sit tight while we get around an exponent of an exponent. Here we go. 4 times 3 is 12. So x to the power of 1 is multiplying, not an exponent of, not a power of, x to the power of 1 is multiplying to x to the power of 12. And using your exponent law, you know that's going to be an addition. The final answer is x to the power of 13. Okay. At this point, some of you are going to just still copy or just try to wrap your heads around it. Other people have seen this and understand it, so it'll be very fast for you. Whatever your pace is, it is your responsibility to understand. So keep pushing. You can reach out to me through email or ask me to clarify. Try some other questions from this sheet and see if it agrees with the answer key that's provided. Okay, hope this helps. Keep pushing on and take your learning to, take charge, take ownership of your own learning. Just because I'm not there, don't dilly-dally. Take it seriously. Okay. And I will see you when I get back.